This is the tensile stress test of various metals. Polycrystalline copper. The elastic modulus is that a substance's resistance to elastic deformation. This is calculated by dividing the stress by the strain and uses the symbol E. The yield point is a point where the plastic deformation starts happening. Tensile strength is the peak stress that the material experiences. This is just before it starts necking. Ductility is the ability of a material to plastically deform before fracturing. The percentage of elongation is calculated by the change in length divided by the initial length, times 100 to get the percentage. The percentage of area reduction is calculated by the final area minus the initial area divided by the initial area, also times 100 for a percentage. Resilience is the ability of a substance to absorb energy. This is calculated by squaring the stress and dividing by 2 times the elastic modulus. This is measured in joules per cubic meter. Toughness is the ability of a substance to absorb energy without fracturing. This is calculated by the area under the stress versus strain curve and is measured in joules per cubic meter.
We have aluminum. The elastic modulus equals the yield strength over 0.2277%, which equals 953.3450 megapascal. We have the yield point, which comes out to 235.81 megapascals, along with the yield strength, which is 217.0777 megapascal. We then have the tensile strength of aluminum, which is 316.192 megapascal. We then have resilience, which equals the yield strength squared all over 2 times the elastic modulus, which comes out to 24.71 joules per mole cubed. The toughness is in the area of the stress versus strain, which came out to 3,352.6. We then have the ductility, which is 5.8448 millimeters. We then take 56.6448 millimeters, subtract 50.8 millimeters, and put it all over the 50.8, multiplied by 100, and we get 11.5% for the percent elongation. We get this percentage from the area final minus the area initial all over the area initial times the 100.
You see the curve it down a little bit, and then come down. And more fluctuating. More versatile. Each of you guys should have a leader with you. Help. So you pass the tensile strength, it's going to break very soon.
Our last metal is steel. The elastic modulus equals the yield strength of 147.2971 megapascal all over 0.1423%, which comes out to 1035.117. Our yield point for steel was 160.6829 megapascal. Again, our yield strength for steel was 147.2971 megapascal. The tensile strength of this steel was 273.9 0.6116 megapascal. Our resilience again is the yield strength squared all over 2 times the elastic modulus, which came out to 10.48 joules per mole cubed. Our toughness was 10,826.8 megapascal. Steel's ductility was 22.064 millimeters, as you can see in the photo. We then have the percent elongation, which is 72.864 millimeters minus the area initial of 50.8 millimeters all over the 50.8 millimeters multiplied by that 100%, and we get 43.4% elongation. You can see this in our graph right here, the tensile stress to tensile strain.
Later on, when you pass the Pinto stress, because naked, where thin becomes concentrated in a specific form. Now it kind of reached the Pinto stress, the biggest stress. So we should be expecting the neck.
Soon enough, you'll start to see a faint line when it's about to break.
Do you see the necking now? It's concentrated, like the plastic shape change is concentrated at a specific point. Now it's very obvious. It's very good.
From the clip given to us from the movie Spider-Man Homecoming, the clip shows a ship being split in half and Spider-Man attempting to web it back together using his silk. As the ship is first falling apart, Spider-Man asks his AI to find the strongest parts of the ship. He does this so when he attaches his silk, the ship does not break, and meaning his webs fail and the ship sinks. But in the movie clip, he misses a single spot to web up, and this puts too much strain on all of the other webs. This leads to all the webs elongating and breaking. Spider-Man then has to stand in for the webs and hold the two halves of the boat together.